Ladies and gentlemen, hello and welcome back to Dubious Engineering. I have a new toy or a new tool or whatever you want to call it. It's a Hantek 2D72. And what I want to do is I just want to run through this thing and figure out, is it worth the money? Is it useful? At the moment they're selling for about £60 on Banggood. It's an oscilloscope. I have other oscilloscopes. So I have other oscilloscopes like this Tektronix TDS210. Again, another little 2-channel 60 megahertz oscilloscope. Anyway, silly scope. This guy claims to be 70 megahertz. And it's got a multimeter on it. It also has a function generator connected to it as well, which is sort of cool. So why don't we have a little play with it, put it through its paces. It's not going to be perfect. We know that it can't be as good as something like this. The front end on this type of scope is going to be absolutely magnificent. Let's give it a test. Here goes. This then is the Hantek 2D72 handheld oscilloscope. So straight out of the box, this is pretty much as it comes. There was a nice little package over the top of it, a bag to stop it from getting scratched up, and a screen protector. You get a USB, a very long USB-C style charge plug on one end of a charge cable. This doesn't come with it. I chucked that in there. It's an Apple iPhone power supply, and you get one of these little guys here, which is a UK to various multi-adapter type sort of plug. That yeah, chuck that away. And also you get one of these charge adapters here. Yeah, I'm not going to bother with those. They're quite useless. So we'll keep the Apple iPhone charger in there because I've got a few of those kicking around. You get a little certificate, blah 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 blah. So this is an 80 megahertz times 10 times 1 switchable scope probe with the little hooky thingy on the front of it. You get a pair of meter leads with it, which are sort of useful, some nice spiky ends on those. And then we have a few packets of silica gel to make some tea with. Definitely don't do that, that'll hurt. And we've got BNC2 or crocodile clips, 2 of those in here. So actually not a bad bunch of stuff really. So that's the box, nice protective case and all the rest of it. Very sort of cool. Right, let's have a play with our new toy. It's got a stand on the back of it so you can stand it up. Fantastic. And as you can see at the top here, we've got 2 channel inputs and 1 signal generator output. At the bottom, we've got traditional sort of multimeter style connections, little banana jacks, 4mm banana jacks. We've got one for current, 10 amp max, unfused it says. That's interesting. Most meters put a fuse in there. So we've got an unfused 10 amp input, a little bit scary. We've then got 200 milliamps fused input and a standard sort of voltage resistance, capacitance and diode check input here, rated at category 2 600 volts. So that's sort of cool. What happens when we turn it on? I've given it a full charge. Okay, green light pops on, display fires up, and boom, look at that. So now I need to set this up so that you can see what I'm doing when I hook it up. What we're doing then is we're just comparing 2 scopes. Quite an easy scope to drive, this Tektronix scope. You can see here we can adjust the vertical position, and then we can adjust the gain of the amplifier in the channel. So currently it's set at 2 volts per division. So each one of those little 10mm squares there is 2 volts. So that's about 5 volts. And indeed it should be, because if we look down here we can see we are looking at a what's called probe compensation output, which ultimately gives you the ability to be able to adjust your scope probes to make a nice clean transition square wave. So and obviously then we have the ability to adjust here with my black 3D printed knob the horizontal position, and we can adjust the time base as well. So quite easily we can get right in there and we can have a look and see what those corners look like on those square waves, and how fast the rise time is and all that kind of good stuff. So that's nice and easy to drive, isn't it? Right, let's have a look. Oh, hello me. So let's have a look here at the Hantek. So we have here the ability to, using the up and down arrows, to adjust the time base. And then if we change between time and channel, those up and down arrows then effectively give you the ability to change the vertical position, and the left and right arrows give you the ability to change the gain of the amplifier inside the channel. So yeah, it's a little sort of that I'm sure they could have made this a little easier to drive. And here then, using up and down with time base, we can then start adjusting the time base of the scope itself, and we can then start sort of zooming in on certain features or zooming out on the frequency and all that kind of good stuff. Yeah, so right, well that's a relatively simple test. And I haven't plugged in channel 2 yet. Maybe we should just plug in channel 2 and set that up and make it look the same. Here is channel 2, so if we go to channel and we change with F1 to channel 2 and we turn on channel 2, there we go. Channel 2 is now active. It's scrolling across the screen probably because we're triggering now perhaps on channel 2. Let's have a look and see which channel we're triggering on. Yeah, don't know. There's a trigger button here, so if we press the trigger button, the source should be channel 1. So on the right hand side of the scope here, we can see that we can adjust the trigger level, and this is yellow, so it's associated with the yellow trace, and the yellow trace is channel 1. So now if we adjust channel 2, source channel 2, and go that way, is that voltage now? You see, this is where sort of we're in trigger mode. No, we don't want trigger, we want channel, and then go back to channel here. We should now be able to adjust the position, the vertical position of channel 2. So there we have it. Now we have two waveforms that look very similar. Now bearing in mind this is a 1 kilohertz, I believe, or 10 kilohertz. I think it's a 1 kilohertz frequency, so this isn't particularly challenging. 1 kilohertz, this is sort of audio frequency. Let's find something a little bit more challenging for these scopes to look at. What I've done is get out my lab power supply. It's got a little 24 volt switch mode in there, and then there is a buck converter PCB, and that gives you the ability to vary the voltage of the drive output. And then what we've done is we've connected just one channel each from these two scopes. If I just press the on button, not on, if I just touch a button here, it'll light the screen up. And as you can see on the screen there, we have got a little bit of noise on the power supply, which is sort of what I'd expect with a switch mode, and this scope is basically saying the same thing. So the frequency is 25 microseconds per division on here, which it's a little bit short of 25 microseconds per division. This guy, just press a button again to turn the screen back on, this guy is 20 microseconds per division. So this guy here is 20 microseconds per division, and you can see it's pretty much a perfect division on that. So 1 over 20 microseconds per division is about 50 kilohertz. So there we have it. We have a 50 kilohertz noise. This guy is showing, let's just have a quick look here at the amount. So let's just go down here. So that's about 2 divisions of noise, and we are in voltage range of 20 millivolts per division. So what does this guy say we have? Again, 20 millivolts per division. We've got sort of one and then a little bit of variation, a little bit of peaking, a little bit of spiking going on there. So yeah, 20 to 30 millivolts per division perhaps. Certainly this waveform is a lot more stable and a lot easier to read. This scope is a lot easier to drive. Then that said, you can find these for about £100 on eBay now. And this guy here then at 60 quid. You know, yeah, not bad, not bad, not bad. Again, 50 kilohertz, I don't have a proper function generator here, so I don't have the ability to be able to throw together you know, a 1 megahertz or 20 megahertz output. Although I do have a bit of ham radio kit downstairs. Okay, so here we have a piece of ham radio equipment. It's a transceiver, Morse code transceiver that I made many years ago. I've worked in many countries on it, and what I believe I'm going to be looking at is the local oscillator re-radiation from the internal oscillator. We're not going to be doing any transmitting with this. I don't have a dummy load and I haven't got an aerial plugged into it. So we're going to look at local oscillator re-radiation coming through the antenna socket. And if you listen, yeah, you can hear a little bit of something going on there. This here is the antenna socket on the side of it, which is a BNC port. What I've done is, and there's a right old rat's nest going on here, sorry about that. What I've done is I've brought that out here, and I've connected both scopes to the same point, to that antenna socket. So what have we got? Well, here, if we just rotate that ever so slightly, there we've got 2.8 divisions at 25 nanoseconds per division. Bear with me a second. So that is a frequency of about 357 kilohertz, which wouldn't surprise me that that could either be an IF, an intermediate frequency of the receiver, or it could be, I don't think, it might be the local oscillator frequency, because that's just mixed then with 20 megs. So here's the fun bit then. Let me just move that and turn the volume down on this thing. Here's the fun bit. Let's press the auto button on this scope and see if it can figure it out. And a few relays clicking and a little bit of waiting, and look at that. That's not bad. That's pretty good. Let's just have a quick check, make sure it's found the same sort of signal. So what we're looking at, 20 nanoseconds time base here, and the other scope was at 25 nanoseconds, and 100 millivolts per division. So yeah, about the same sort of amplitude. So we're looking at 400 millivolts. It's a little bit irritating that it keeps blanking the screen. I'm going to have to go and change that in a minute. In fact, I believe if I press a menu option there, backlight timing, backlight timing, there we go, 30 seconds, 60 seconds, 90 seconds. Yeah, there you go, 120 seconds, right, good. That's a little bit more like it. Enter. Cool, so there we go, we're about 0.5 megahertz, and we're still looking pretty good with all of that, so not bad at all. Again, the waveform is just a little bit sort of flaky there, a little bit unstable, but then if you look at this waveform here, we're seeing something very, very similar. So not bad at all. I'd like to take it to the next level, like a, you know, sort of 20 megahertz drive output, which actually I could do with this box, but I think I'd like to try this unit's function generator next. These are some of the countries that I worked in Morse code with this thing. I must admit, I don't think my Morse code is going to be very good now. I've worked quite a lot of Europe with this little machine. A 12-volt battery, a Morse code key, and an antenna. Maybe we'll get that out again one day. It's sort of good fun, but interesting to see that happening. so let's have a play with the function generator. It's quite easy. You can literally switch between scope and function generator. You go AWG here, and then you have the function generator. And at the bottom here is a little green play button. If it's red, the output is turned off. And I'll show you when I press the button here. When we turn the output on, we can see the output appear on the Tektronix scope here. So frequency is currently 1 kilohertz, and the amplitude is 1 volt peak to peak, and it's a sine wave. So let's just have a look at some arbitrary ladder waveforms. There we go, ladder waveforms. Press the button, ladder in the opposite direction. Yeah, we've got some ringing, which is quite interesting. And yeah, this is actually, and then we get back to, you know, sort of traditional square waves and stuff like that. But that appears to work. Let's just wind that frequency up a little bit then. So press and hold the button, and you can see that that just starts filling up the screen. We are at 36 kilohertz or so. So let's just hit the auto set button on the Tektronix scope. Bang! Look at that. I must admit, that's fantastic. That's a little bit of ringing going on there. That might be down to the scope probes and the drive out and that kind of stuff. But let's keep going with that frequency. Let's see where this gets to. And there we go. All of a sudden, we're into high speed. So we're 400 kilohertz, 570 kilohertz, and we're just getting higher and higher and higher. That's quite good. 900. Right, we're in megahertz now. There we go. Up to 10 megahertz is our maximum frequency. Let's press the auto set button and see what the Tektronix scope makes of that square wave of 10 megahertz. Well, it's not entirely a square wave, is it? Let's face it. But yeah, it's still a function generator, you know, again, included for 60 quid. It'd be quite funny. Let's put this into... it is actually trying, look. My goodness, it is actually trying. Yeah, that's really quite cool. Not bad at all. That's pretty good functionality. All right, excellent. You know what, and it's dropped it down to 1 megahertz when I did that. So but yeah, it looks like, yeah, there we go, it's closing things in. It still works. Ooh, right, output amplitude has just diminished significantly there at 25 megahertz. So yeah, it's an interesting bit of kit. There we go. As you can see, as I come out of the as I bring that frequency down, yeah, that amplitude comes back. So yeah, all right. So not bad, not bad. I mean, you know, it works, doesn't it? Sort of. It's not a Roden Schwartz or anything like that, but not bad for 60 quid. And then finally, I suppose we should probably just sort of quickly test the digital multimeter mode. All the scopes and all that sort of business to one side now. Just literally just plugged it straight into my power supply. Power supply says it's running at 11 volts, 11.1 volts. Meter says it's at 11.08 volts. In fact, I'm more inclined to believe this Chinese meter than I am this device here. But as you can see, I can turn the voltage up and we get readings. Yeah, and then in here we also have the ability to check resistance, continuity, and we've got DC amps, DC milliamps, millivolts, AC amps, volts, and then we've got a capacitor check and a diode check as well. Very good stuff. Not bad at all, guys. Hantek, finally, something from Hantek that actually isn't a million miles off of being useful, certainly for the money. Quick note whilst we're having a look over this in a little bit more detail here. A couple of guys asked in the comment section of a previous video, could I make a video about how to use an oscilloscope? It's quite a long and interesting topic, and I must admit there's quite a few videos already on YouTube that definitely do that. So please go ahead and just sort of, if you're interested in a little bit more detail on how to use this equipment, then go ahead and check out some other people's videos. They've made some really good videos, so well worth checking out. Ladies and gentlemen, thanks ever so much for watching. I hope you've enjoyed the review of the Hantek 2D72. If you have any other questions, please pop them in the comment section down below, and I'll do my best to answer them. Yeah, not bad, certainly for the money. For a nice digital display, lithium ion battery, portable, it's got a lot of functionality in it for the money. So certainly not bad, not perfect, but not bad at all. Thanks ever so much for watching, people. Take care, have a wonderful week and weekend. We'll see you in the next video. Don't forget, thumbs up, subscribe. Cheers and beers, people. Bye for now.